All right, guys, let's settle down. I mean you, church. Settle down. All right. It's a pleasure to welcome the acting chief scientist of NOAA, Craig McLean. I would hope that there were not that many acting people in NOAA, but hopefully we'll get that sorted out soon. It's all yours, Craig.
Pablo, thank you very much. Good afternoon, or actually, good morning. It feels like afternoon. Good morning, ladies and gentlemen. I apologize for keeping you delayed here. We were just in the discussion with some of the media folk who were asking some very insightful questions, and I think the nature of a symposium like this really provides an enriched public understanding of some very challenging questions. So once again, to applaud the organizers of this forum, and I appreciate the opportunity to be here. I've been preceded by other far more qualified and eloquent spokespersons from NOAA over the years, and I hope to at least keep the bar somewhere near the median point of that. But if we look at the current state of the Arctic, it is an area of rapid change, and our scientific recipe or our scientific instruction given to us by the Congress is rather rich and requires us in NOAA to be collecting and formulating a lot of information in measurement and then offering conclusions as to what those measurements might spell. So if I take a step back now, I think a lot of folks here are probably familiar with NOAA, but I'd like to offer, for those who may not be, a rather short characterization of our mission. We're challenged to answer some pretty tall questions. First question I would offer is how many fish are in the sea? And that's a toughie. And I'm not sure anyone really does know the answer, short of ecclesiastical references that people might be able to make. But in terms of how many fish are in the sea, that is the job of our National Marine Fisheries Service, which is a major portion of NOAA. That's an organization that's been around for over 100 years, and their job, our job, is to conserve and manage living marine resources. We do so under various very detailed levels of instruction from the Congress through the Magnuson-Stevens Fisheries Conservation and Magnuson Act. We provide the science, the community through fishery management councils provide the insight and the direction for regulations that seem to make the most sense to the community at large. And there's also the reserve function in the law that if the direction that the council-led management is taking is not appropriate for the health of the stock, then the Secretary of Commerce can step in and override regulations and provide a different direction. All of that complication to suffice to announce that we do, in fact, endeavor to count how many fish there are in the sea and then set an appropriate level of harvest so that those stocks are healthy, viable, and could continue to provide nutrition and a robust economic future for people who participate at the various levels of business transaction and fisheries. At the same time, we're trying to preserve the marine environment, and that includes Marine Mammal Protection Act and Endangered Species Act as well. So if you apply that to the rather newfound area of the Arctic, because we've not been fishing in the Arctic and we've not done much work in the traditionally described areas of the Arctic, that's a task ahead of us, and that's a task we've just recently begun to undertake, but there's a lot of work, a lot of science, and as the Admiral's comments just earlier this morning led, it is science-based decision-making that we endeavor to practice. So we want to find the science before we make public policy decisions. So how many fish are in the sea? Second question. What's the weather going to be like tomorrow? A lot easier to answer nowadays. You can just look at your Palm device in your pocket and read it. But that information comes from largely the tax investment of the U.S. citizen who puts money forward into NOAA's budget, where we spend at about 2.5 cents a day for weather forecasting. We give it to the world. We give it to all the private sector, and we give it to everyone. And you can get it on your Palm device. But what's the weather going to be like tomorrow? It started as a pretty complicated question with sophisticated observation systems, modeling, and now our ability to forecast quite reliably within about better part of 5 days. And we're trying to push to make those forecasts even better into the future, and we spend a lot of time, a lot of money, and a lot of effort in order to do so. The challenge for us in the Arctic is that we don't have the Arctic as well monitored, measured, and quantified as we do the other traditional parts of the United States where our jurisdiction for weather forecast really arises. So for us to look at installing the types of monitoring systems that would be necessary to make, for example, Alaska and the very important people who live up there as important as citizens in any other state or territory, in order to have Alaska as well monitored as we do the lower 48, there is a gap that we would need to close. And that's something that we would work towards or are working towards. But in terms of also some of the other complexities of weather forecasting, there are aspects in the Arctic that we just don't see anywhere else. And you heard from two previous mariners. I'm a short mariner. I was in the NOAA Commission Corps and retired as a captain. Never navigated in the Arctic waters myself. So I have a great deal of respect, also a great deal of mystery in terms of how challenging that may be. But the forecast elements for the Arctic are very different than they would be for other parts of the world. So I'll mention a little bit more of that shortly. Then we also have the question, if you can answer, what's the weather going to be like tomorrow? What's the weather going to be like 50 years from now, 100 years from now, or more? And that's climate science. And we have two authorizations in NOAA that instruct us to undertake a study of climate and to be able to report those results for science-based decision-making. And we undertake that mission with rigor, and we apply it in many different areas. We apply it inside our agency and outside. Our fisheries folks are working with our climate-derived information in order to try and forecast what the ecosystem will look like in the future. At what latitude might we find the fish stocks that today are predominantly in a habitual latitude? Rates of change are being noticed, and we're trying to quantify that and look forward to the economic future as well as the ecosystem and biological future. So how many fish? What's the weather tomorrow? What's the weather like 50 to 100 plus years from now? And then the last one, is it wise to build on shifting sands? I'll not cite a reference for that, but the notion of coastal zone management and our ability to sustain the ecosystem-based, economic-based quality of life as American citizens enjoy on the coast are practiced throughout NOAA, through the Fisheries Service, through Sea Grant, through the Coastal Zone Management Program, through many components of the NOAA budget and NOAA programs that have been around for decades and have continued to serve the American public quite well for quite some time. And if you pause to remember that better than 50% of America's private wealth and private individuals reside within and around that coastal belt around the United States, that's a significant portion of our population, our investment, our economy, and the economic engine of the coast is something that we also look out for. Looking at these ties, you can understand that NOAA being set and organized within the Department of Commerce brings a different level of interaction. So we are, in fact, a science-based mission agency. Our mission is described, excuse the cartoon character of it all, but along the lines of those four questions that I've outlined here. And they are quite tall and demanding questions. So the science enterprise that we've constructed in order to answer those goes back to the various line functions that we have of the National Marine Fisheries Service, the National Weather Service, the National Satellite Data and Information Service, or NESDIS, then also the National Ocean Service, and then finally the organization in NOAA that I'm responsible for today is the science organization that looks out over the horizon and into the future to try and provide tools, methods, models, and manners of doing business in order to answer some of those questions. So in terms of what's happening in the Arctic, this is an audience that doesn't really need to be reminded of that, but to just review the general notions of what we see happening as we record and measure warmer air temperatures over land masses, melting of ice, minimums that we increasingly perhaps have not seen before, the ice sheet in Greenland starting to melt at an earlier onset each year, the notion of ocean productivity now being measured at rates that either we haven't had access to measure before, or what we're measuring, we're now seeing something that's a bit of a surprise to the biological community. And we're looking at, again, latitudinal migration of some components of the ecosystem. So there is a very rapid, relatively speaking, in a geological timescale, there's a rapid rate of change going on in the Arctic. And the Arctic is also, as we've seen, breaking up. The traditional weather and cycled patterns of circulation in the Arctic are breaking up and leaving the Arctic. So not to be cute, but what many people are reminding us is that what happens in the Arctic no longer stays in the Arctic. And it's influencing at rates yet to really be measured, rates yet really to be quantified, but there's a strong signal that the Arctic breakup is starting to influence that which happens in, for us as Americans, the lower 48 and other parts of the world. If we look back at our approach to this inside of NOAA, I show for you here up on the left-hand side the national strategy, which has been around since 2013, and we had generated in and around 2011 this NOAA strategy for the Arctic. And these comport generally with the missions that I've described earlier. And you'll hear much more detail about these from speakers that will follow us. But if I could just give an overtone or a setting of the stage for this, the forecast of sea ice and improving our weather forecast really brings in other elements that we don't traditionally get involved in and requires our ability to make new forecast tools in order to be looking at some of the components of ice-based forecasting. We don't really have that kind of environment anywhere else in the United States other than in Alaska and beyond. So our weather forecasting is an area that we need to focus on in order to make more robust and more complete in measurements, models, and forecast tools as we wind up seeing, as it may develop, more activity in what could be an ice-free Arctic. If we look at the foundational science and our understanding, there's a nice trilogy here that starts with foundational science. Perhaps I can illustrate a little better here. I'm sorry. Thank you, Pablo. If we start with foundational science, then move to stewardship and management, we're applying that foundational science to the stewardship and management requirements that we have. And by doing so, we then could advance to a state of a healthy and robust Arctic. The people of the Arctic are very much a part of this. There are populations of people, there are native populations of people, and then there are also the general residents of Alaska that we have to look for. And as I iterated those mission spaces that NOAA has, you could see that our science-driven mission and those mission requirements are very much oriented towards people, community, and economies. And we do so through the application of science and science-based decision-making. That's a theme, I think, that's throughout any agency that has the business profile or the mission profile as we're talking about here. That's another area that we've committed to through this strategy. And right now, we, as the Coast Guard has told you and shown you, we don't have the icebreaker capacity to be up as long and as often as we would like to be in order to do the kind of science that's necessary. We're looking at under ice tools that can allow us to traverse the Arctic and make measurements without having to disrupt the ice at the surface. But we're looking really at science solutions anywhere we can find them. There's a lot of international collaboration in these areas, and in the work that we've done over several years with Canada, for example, in developing our profile in a shared way for the potential extension of the continental shelf. I think that extended continental shelf work has been very importantly guided by the Coast Guard. NOAA provides funding, and we've had cooperation from the Navy and others in order to do so. And somewhere along the lines, I saw Larry Mayer in the audience here, and you'll hear from Larry shortly, but he's really been the U.S. lead in bringing this all together. His will be, I guarantee you, a fascinating talk, and also to be able to see how much of the Arctic we do know about physically, and how much we have yet to learn physically. So the international partnerships, as I mentioned Canada, as I mentioned other nations that are very much a part of this, enable us to bring capacity to the Arctic that we ourselves don't have inside of NOAA or through other means. Our investments in the Arctic have remained relatively constant since about 2013, 2016. We're at a total of around $125 million if we were to draw a circle around those programs or activities that are executed in the Arctic. And this largely excludes our satellite surveillance. As you know, NOAA has polar orbiting and also geostationary satellites. And if you've not gone on the web and looked at some of the new GOES 16 imagery, it's pretty darn exciting to see what the fidelity of those images might be. And what really excites us is that those images from satellite are now matching the fidelity of radar-scaled, ground-based radar-scaled images, and that opens up entire new doors and avenues, if not highways, for scientific understanding of weather phenomena. So we're very excited about that. But excluding satellites, we're at about 125 million. And you can see the general percentage breakout here, and as we track the national plan of looking at responsible stewardship, that's where most of our money is taking place here. And frankly, most of that is in the already surveilled and measured and monitored areas of the Bering Sea, and not really getting too far up around the corner into Chukchi and not yet into the Beaufort. But we've got most of that activity in that area is in the Bering Sea and looking at marine resource bases. We've got to get around the corner. We've got to devise the methods, the tools, and the practices in order to do so. But you can see the distribution, and I think it's visible enough. I'll not call each of these out for you as we go, but I think it's important to understand generally where our funding is. And then if we look at a geographic distribution here, reinforces the point I just made, you can see where most of our activity is. So by this profile, at a level of spending of approximately $125 million, this is status quo. And as we work to reach beyond that, go farther north, go north and then east, and really cover the full area of a U.S. EEZ, but then also cover the area of that global Arctic. It's very important for us to do that, to be convening in an international sense the collaborations that are necessary to monitor and measure the Arctic at a pace, scale, and tempo beyond where we are today. And that's what's going to be necessary for us to really understand the phenomena that's taking place as the Arctic breaks up, as the Arctic then starts to influence other parts of the world through global circulation and in an oceanic and also an atmospheric sense. By the way, worth noting that for our application of Arctic, according to the Arctic Research and Policy Act of 1984, we've defined the Arctic to extend a bit below the Arctic Circle, and it includes parts of Canadian land, we're not accessing Canada, I beg your pardon, parts of Alaska mainland, and also the Aleutians and components of the Bering Sea. So we're looking at it more from a large marine ecosystem perspective rather than just the singular Arctic Circle. But the fish stocks that are very much involved there are transboundary if you choose to respect the Arctic Circle as defining that which is within the Arctic. But it's a complicated area, and it is requiring more of our scientific focus. Here's a nice placid picture that we'll just leave as a recruiting poster for why one wants to research the Arctic. We have a lot of people who are very interested in working on coral problems and tropical and semi-tropical environments, but clearly the Arctic is a harsh place to work, only because this is one of our newer fishery research vessels that we're very proud of. This is the Oscar Dyson, and it's a photo that was made in the Bering Sea, but there's another Bering Sea photo that NOAA used a long time ago, and it's a Kodachrome that's so badly faded I didn't want to insult you with the likes of modern graphics, but it was of the Miller Freeman, which is an older fishery research vessel. And our work is not as compelling in a life-saving nature as would be the Coast Guard's work, to go up and rescue mariners that are in distress. But we still find ourselves up in the middle of storms, in the middle of weather that we would prefer not to be in order to answer those questions I raised earlier. And one of them is to determine the health of the fish stock in the Bering Sea, upon which major industries are focused and founded. But this other photograph I'd love to have shown you is of the Miller Freeman in some rather large sea state, and one of the windows on the bridge is covered with plywood because it had earlier in the day blown out, taking a wave over the bow, and this was a rather handsome-sized vessel of about 210 feet. So the exposure, the extremes, working in the Arctic, well known to the Coast Guard, well known to the commercial fishers, but also well known to some of our fisheries scientists and our crew members in the NOAA fleet. So we're up there as part of that community, making observations, trying to make these measurements, but what we depend on also are the same weather forecasts that the Coast Guard needs, that the commercial fisher needs, and that's a burden that falls on the shoulders of our National Weather Service. So they're rising to the challenge, but as the Arctic opens up, that's an area we have to do more in. We have to find our way to be doing the science that's uniquely applied to the Arctic, and I think you'll hear a little bit more about that as well. So another area that I want to mention, I'll go back to, is the nautical charting of the areas in the Arctic. You heard this morning of navigators using charts that had, in some cases, lead line soundings as the basis of it with a 1912 datum, but it even gets worse than that. There are parts of Alaska where Captain Cook and his colleagues made soundings. And in some cases where you don't have shifting, drifting sand masses, you have hard rock bottom and the like, there's a reasonably high degree of reliability in those charts, but not the kind of reliability that you would want to place any hope or reliance if you had the alternatives of multi-beam echo sounders, where you could really get a three-dimensional picture of the seabed. And we currently have 2 ships operating as wide as the season is long and as long as it lets us operate up in that area. Unfortunately, those 2 ships are almost as old as I am, and closing in on that too, because I don't, last birthday was the last one I celebrate, and it just keeps going from there. But these ships are very aged. We need to replace them. And that's something that we have made continued requests in. Actually, in the President's budget is a request for ship replacements, and we're hopeful that we could see some movement in that direction, and we hope that we can get the support of the Congress in order to be there. There are new methods of mapping that are far less labor-intensive, people-intensive, unmanned surface vehicles, the likes of the technologies that we could be using. and are starting to use in the Arctic, they hold great promise, and they can lower our cost of making these observations, bring us away from the traditional levels of spending. If I move past that, into the national strategy level of effort number 2, advancing security interests, one could look largely at NOAA and raise the question, is there a relationship between NOAA and national security? Well, clearly we have the likes of our national defense enterprise, the military services. We have the coastal, and included as a military service is the Coast Guard, of course, but the work that the Coast Guard, Department of Homeland Security at large, other agencies fill. I am delighted to hear more and more, particularly from our naval oceanographic community and the naval operating community, how much NOAA's observations, models, and forecasts are being used as part of our national defense readiness structure. Simple questions as to what will sea level be in what year, in whether it's the Arctic or in Alaska ports, is as germane to us as is that same question for whether or not the Tidewater area in Norfolk and the Naval Operations Base will be submerged, how often out of the year. So we are increasingly being relied upon by the national security enterprise to be providing this information, including the climate forecasts that we generate, model, and disseminate quite routinely. So this applies to the national security envelope, but it's accomplished through foundational science. It's accomplished by applying that foundational science through the stewardship and management questions, but also relies on an intergovernmental community and international collaboration and domestic collaboration and cooperation. That brings us to the last level of effort of the national strategy that we're very much involved in. And through the World Meteorological Organization, through the Intergovernmental Oceanographic Commission, where I represent the United States at that IOC, it's part of UNESCO, but the work that's done there through oceanic and weather-based observations really go into a global exchange of information so that Canada, Russia, Denmark, every nation of the world can enjoy those observations, particularly as they are made in the higher latitudes. But we also have interaction with the local communities and the independent institutional governance of those local communities. And this is a very important component of the Arctic. This is the people part of the Arctic. In addition to those citizens of Alaska who might have arrived there later in time than did the native people, the native populations of Alaska are a very important component, and through our Sea Grant and Coastal Zone Management Program, we work very, very earnestly in order to understand the needs that these communities have and in order to understand how we can bring benefit to those communities in a way that not always does the rest of the economy find a way to bring them forward. And in some cases, bringing communities forward is not the answer, where one wants to maintain the heritage and culture that has brought the people to the place where they are today. So there are a great many levels of interaction, and I hope that you will indeed hear more of those today. I'll close with a notion of our participation in an international Arctic observing network. And, excuse me, return to that slide. You can see where these little colored dots in the upper left-hand corner, hopefully you can read. I believe you could read some of the abbreviations of just what the different types of measurement systems are here, but rather than getting into a detail on that, I think there'll be more talks and discussions on this. But a point I'd like to make here, as I mentioned, there are two Arctics, if you will. From the United States perspective of a 50-state union, we have Alaska that we're very concerned about to provide the services that the citizens of Alaska need, whether they be mariners, coastal watermen, or people who live inland. And we need to be providing an appropriate level of service to Alaska as we do to the lower 48. Additionally, there are the global science questions which take us north of where this map is and into that polar ice cap and into that cryosphere, into that global ocean that we know as the Arctic. And many of our programs are focused, as you saw the distribution of our spending, much of our spending is focused on the state of Alaska and the coastal environs there for fishing, for coastal management, for weather, et cetera. That larger top of the earth, if you will, top of the world, is a portion that we deal with in global ocean science, global atmospheric science, and global climate science. That is not currently the heaviest level of funding that we have. It's more towards providing the services for the people in the state. And then I'll return to the theme that I started with. We are, in fact, a mission-driven science agency. Those missions are very certainly described for us in law, And the Congress has prescribed those areas that we maintain our focus in, also funds us in a manner very similar to those areas of focus, and that's pretty much where we find ourselves. But please don't be misled by this diagram. This is where we're focusing in our application of the U.S. portion of a joint international Arctic observing network. But our observations, as you'll hear, and perhaps you already did hear, I'm sorry, I was in the media center just now, but perhaps you heard from the Navy some very impressive work. You'll hear more about the work that the Navy's doing in some of the physical ocean measurements and the like. There's a lot of work going on in the Arctic. I think we need to continue this, do more, and I think you'll hear more from some of the following speakers. So thank you very much for your attention this morning, and I congratulate you on the forum and the rich exchange of information we have here.
Thank you, Craig.
Pablo, thank you.
Let's open up for questions. Very shy audience. Really?
I think I made it easy for everyone, Pablo.
No, there are plenty of questions.
I think if you heard the question the gentleman asked is, in NOAA's opinion, are we ready for a major oil spill? And I want to go back to the Admiral's comments this morning, where the Coast Guard, who would be the on-scene commander for an oil spill, would really have that informed decision, the decision-making authority and be the on-scene commander. NOAA's role is to provide science advice. And there's a lot of science at many different slices and levels that I think are worthy of continued study and worthy of continued investigation. And I think that this is a policy question that the nation will have to wrestle with. How much of what you do know is sufficient in order to take a particular activity and go forward? And as we've seen before, there had been licensing for exploration in Arctic areas. So one can explore to an infinite potential, the scientific certainty, or one could be looking at what we know today and do we move forward. That's always a policy question rather than a science question. I think in terms of science, we would always love to know more. Thank you.
Are you allowed to answer politically sensitive questions? I'll throw them.
I really enjoy Pablo's sense of humor, and
I'll throw them at you, and you.
Let it roll,
Okay,
Pablo.
first one. What does NOAA's budget look like as we move forward with the new administration? Is there still support for climate science? What about the Arctic? Actually, that was 3 questions.
So I'll start with the question of what does the NOAA budget look like. It's certainly it's a matter of public record. The budget process is continuing to evolve. As we know, the Congress, it's written in the Constitution, the Congress makes the budget for the federal government. So far, we've heard from the House, and we understand where the numbers are on the House side. We've heard the President's request as well. And for detailed questions about the NOAA budget, the party that's been identified to answer those most thoroughly is at the Department of Commerce level, so I'll make reference to further follow-ups with the Department of Commerce. But you could see that in the President's budget, there were reductions that were made in order to shift money from the discretionary accounts to the national security, the southern border, and to the national defense accounts, and those are obviously very high-level decisions. Where we find ourselves now on the House side, still evolving, is to a certain extent some restorations of some of the proposed reductions that were in the President's budget, but climate science took a proposed reduction, but many years we've seen proposed reductions coming from either the Congress or the executive branch, and we're currently able to maintain a robust operation and a robust series of measurements around the globe in order to assess the state of the climate. The second half of that question, Pablo, please.
No, I think you covered it.
Okay, very good. Thank you. Thank you.
Please.
Yeah, I think I'll include Alaska in amongst the 33 Sea Grant programs that we have around the country. And the Sea Grant program has a 700 and some % return on investment. And that is remarkable. And Sea Grant does a very dedicated and loyal job of documenting their economic contribution in addition to the science that they perform. So the Sea Grant program has been very important for local economies, for aquaculture, for many different areas of the vibrance of coastal communities. And it's a widely respected, highly regarded program. Alaska Sea Grant, I think there's a really easy website to look through and see the economic contribution that's made from each of the Sea Grant entities. As you know, Sea Grant is a program that is leveraged with state money. So for every federal dollar, there's at least 50 cents contributed by the states. So Alaska Sea Grant has been very helpful to the safety of mariners, helpful to translate in an understandable way some of the complex fisheries regulations, and helping businesses get established and sustained.
It's interesting because with that answer, you partially answered this question, which I was going to pose, and maybe now it's not necessary, but just for the heck of it. How is NOAA mandated to advance resilient and healthy Arctic communities and economies? So certainly through Sea Grant, that's one way, but if you want to expand.
In terms of NOAA's instruction to enhance the vibrance and the economic wellness of communities, the Coastal Zone Management Program is one where we look for consistency across states in taking action along the coast so that the action of one state doesn't unwittingly or unnecessarily harm the action in an adjacent state, and that we look for some measures of conformity in terms of what is happening along the U.S. coasts, balancing the developmental opportunities and economic prosperity that usually accompanies that with preserving the environment and protecting the ecosystem, which also delivers prosperity and components of the economy. In the National Marine Fisheries Service, there's a significant degree of consultation and understanding of economic prosperity to those communities that are served by commercial fishing access. So it's pretty much distributed throughout our being. The National Weather Service on a daily basis provides the public with decisions to enhance your economic prosperity, your individual safety, the wellness of your community. It's really across the entirety of NOAA's portfolio.
And I'll take a couple of minutes from lunch, since I'm not having any lunch. It doesn't matter. And give you one more question, and then we can close. How does one close, how does one close the Arctic forecasting gap with manned observations, improve automated observations, leverage satellite observations, anything else?
How to close the observing gap?
Forecasting gap.
I think there are a couple of ways. Increasing, particularly in the northern latitudes, increasing the density of observation-based platforms, whether they be in situ or, as in situ, whether they be buoy-based, land-based, mobile, gliders, drifters, and the like, and buoys that can penetrate the ice and send their signal and transmit their information throughout the 360 days, 65 days of the year. But we also have remarkable gains that are coming to us through our models based on the observations we're able to make so far. The modeling capability is extending quite rapidly. We're seeing some new models throughout development in the university community and federal agencies as well. We're particularly proud of the models that are coming out of our Princeton University laboratory, the Geophysical Fluid Dynamics Lab, where from that lab has been developed through competition and delivered to the National Weather Service the next model core for the weather forecast system. The root of that, it's called the finite volume cubed model, has been applied to such things as Arctic sea ice. And 2 to 6 months in advance, we're starting to see models that are showing skill in predicting the thickness of the ice up to 6 months out. So I think through technology we'll solve some of it, but we also have to increase our observing density. Thank you.
Once again, thank you.
Thank you very much. Thank you.